Imagine lifting your gaze to the night sky and finding a colossal beacon, a world so vast that more than 1,000 Earths could fit inside. That is Jupiter, the monarch of our solar system. From its surface rise stripes of stormy clouds stretching tens of thousands of miles, while around it whirls a retinue of 95 moons, each with its own peculiar story. Astronomers often call it a miniature solar system, and when you picture the scale, it feels less like a planet and more like an entire kingdom of chaos and wonder. For centuries, Jupiter was only a bright wanderer in the heavens, too far away for its secrets to be known. Then came a turning point. NASA sent a small spacecraft, no larger than a basketball court, across interplanetary space to meet the giant up close. Its name was Juno. Against the immensity of Jupiter, Juno looked fragile, yet it carried within it a powerful set of instruments designed to probe the planet's storms, magnetic fields, and interior. What makes this story compelling is not only the science, but the sense of proportion. Imagine Earth as a pebble and Jupiter as a globe towering beside it, and then imagine a human-made craft diving into that giant's realm, armed with nothing but sunlight collected on its 3 great wings of solar panels. That contrast alone sets the stage for an adventure that feels almost improbable. And yet, that is exactly what happened. Since 2016, Juno has been looping around Jupiter, capturing images that no telescope on Earth could ever provide. It has revealed the gas giant's poles, striped in cyclones like cosmic gears, and offered glimpses of moons so unique that some rival entire planets in scale. But among Jupiter's many companions, there is one that refuses to be ignored. A moon so restless, so alive, that its surface transforms almost daily. This is Io. And the closer Juno flew, the more it became clear. The story of Io would not just astonish, it would redefine what we thought we knew about worlds beyond Earth. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. Every great journey begins with an idea, and Juno's story started long before its launch. In the early 2000s, scientists asked a bold question. Could we send a probe into Jupiter's harsh domain and survive long enough to unlock its secrets? The challenge was immense. Jupiter's radiation belts are powerful enough to fry electronics in hours, and the distance from the sun is so great that solar power seems impractical. Most missions this far out rely on nuclear energy. Yet Juno was designed differently. Engineers gave it 3 enormous solar panels, each longer than a school bus, making Juno the first solar-powered spacecraft ever to explore this distant frontier. That decision wasn't just technical, it was symbolic, proving that with clever design, sunlight could be stretched across 500 million miles to power discovery. Launched from Cape Canaveral in August 2011, Juno began a 5-year voyage that covered nearly 3 billion kilometers. To gain the speed it needed, the spacecraft even swung past Earth in 2013 for a gravity assist, like a slingshot that hurled it toward the outer solar system. It's poetic when you think about it. Our own planet lending a push to a traveler on its way to meet a giant. By July 2016, Juno had arrived, slipping into a highly elliptical orbit around Jupiter. Instead of circling the planet in neat, even loops, it traced long, looping paths that carried it close to the poles before retreating far away again. Each close pass, called a peri-Jove, lasted just a few hours. But during that window, Juno's instruments worked furiously, measuring magnetic fields, sampling atmospheric composition, and snapping breathtaking images. Then, like a pendulum, it swung back out to safer distances, preserving itself for the next encounter. What makes Juno fascinating is how human it feels in design. To shield its instruments from radiation, engineers placed its electronics inside a titanium vault, a kind of armor weighing nearly 200 kilograms. Without it, the spacecraft would never have survived even a single orbit. Its camera, Juno Cam, was actually added not just for science, but for the public, a way to bring everyone along for the ride. In a sense, Juno is both explorer and storyteller, carrying the curiosity of scientists and the wonder of anyone who has ever looked up at Jupiter and asked what lies beyond those swirling clouds. And with each orbit completed, Juno was not just circling a planet. It was circling deeper into the heart of a mystery, setting the stage for a meeting with a moon that would change the story entirely. Io, the world of fire. When Juno finally swept past Io, the encounter felt less like a flyby and more like approaching a living planet caught in the act of constant creation. Io is not frozen like Europa, nor quietly scarred like Callisto. Instead, it is alive with fire. Juno's cameras revealed a surface that seemed restless, glowing in patches, reshaping itself almost as quickly as it could be mapped. At its closest, Juno passed just 1,500 kilometers above the tortured terrain, close enough that if you stood on Io, you could almost imagine seeing the spacecraft streak overhead, a silent witness to chaos below. The images were astonishing. Volcanic plumes rose dozens of kilometers above the horizon, taller than any mountain on Earth could ever reach, arcing gracefully into space before raining back down as molten snow. Across the plains, dark scars marked where lava had once erupted, only to cool into glassy crusts that glistened in the sunlight. Juno captured ghostly clouds of sulfur dioxide rising from the surface, drifting like smoke signals from a world forever in turmoil. Among Io's most captivating features is Loki Patera, a volcanic depression nearly 200 kilometers wide. Picture an entire state-sized lake of magma, its surface crusting over, cracking, and resurfacing again in an endless cycle. From orbit, it looked like a mirror of fire, rimmed with glowing edges and dotted with islands that seem to appear and vanish as the lava overturns itself. Loki alone releases more energy than all the volcanoes on Earth combined, a staggering reminder of the forces at work here. Juno also captured the spire of Steeple Mountain, a peak rising between 5 and 7 kilometers high, shaped like the jagged tower of a cathedral. Imagine watching the sun climb behind that summit, while plumes of glowing material burst upward nearby. On Earth, mountains stand as monuments to stability. On Io, even a mountain feels temporary, surrounded by a landscape that refuses to sit still. The cause of this relentless activity lies deep inside. Io is trapped in a cosmic tug-of-war. Jupiter pulls with overwhelming gravity, while Europa and Ganymede tug from other angles. The result is constant flexing, stretching, and squeezing, like bending a piece of metal back and forth until it heats up. This process, called tidal heating, pumps unimaginable energy into Io's interior. Unlike Earth, where heat escapes slowly through plate tectonics, Io's heat bursts forth in violent fountains. In fact, Io may be the closest thing we have to a world-sized laboratory of geological extremes, a natural experiment that demonstrates what happens when gravity itself becomes a furnace. To scientists, Io is both a marvel and a mystery. Its surface is so frequently resurfaced by lava flows that impact craters are almost non-existent. It is a world that erases its scars faster than they can form, giving it the appearance of youth, even though it is as old as the solar system itself. Some researchers even wonder if beneath Io's crust lies a global ocean of magma, a churning reservoir that feeds its endless eruptions. If true, then Io isn't just a moon. It is a world remaking itself in real time, right before our eyes. As Juno continued its long dance around Jupiter, the giant refused to give up its secrets easily. From a distance, its cloud bands look serene, painted in stripes of cream and copper. But up close, Juno revealed that Jupiter's atmosphere is anything but orderly. It is a chaos engine, filled with storms that dwarf entire planets. At the poles, Juno found cyclones arranged in perfect geometric patterns, massive hurricanes locked in formation, like petals of a cosmic flower swirling endlessly around the axis. Each one is larger than Earth, yet they move together with uncanny precision, as if choreographed by physics we don't yet fully understand. Then came the Great Red Spot, the storm that has raged for centuries. Before Juno, we thought it might be a shallow swirl, a weather system skimming the upper layers. Instead, Juno's instruments revealed that this storm plunges hundreds of kilometers into the atmosphere, rooted deeper than any hurricane on Earth. Imagine a storm so vast it could engulf our planet 2 or 3 times over, and yet it doesn't fade. It endures, generation after generation, a scar and a heartbeat in Jupiter's atmosphere. Scientists debate why it survives so long. Is it fed by hidden jet streams, or does Jupiter's lack of solid ground allow storms to stretch into eternity? The mysteries extended beyond the atmosphere. One of Jupiter's tiny moons, Amalthea, surprised scientists with its oddities. Barely 80 kilometers across and shaped like a red, lopsided potato, Amalthea radiates more heat than it receives from the sun. Some suggest tidal forces may be squeezing it. Others argue that electric currents generated as it cuts across Jupiter's vast magnetic field could be heating it from within. For such a small body to glow with unexplained warmth adds another layer of intrigue to this already perplexing system. All these findings point toward a larger debate. Did Jupiter form where it is now, sweeping up gas and ice in place, or did it migrate from farther out in the solar system, stealing material along the way? Juno's uneven water measurements hint that the giant may not have been born where we always assumed. If true, then Jupiter didn't just shape the solar system. It may have rewritten its own origin story. And if we can't yet solve Jupiter's mysteries, how much less do we truly know about the hundreds of gas giants orbiting stars beyond our sun? Every mission has a finale, and Juno's story is already moving toward its last movements. With each orbit, the spacecraft dips closer into Jupiter's embrace, gathering data while bracing against the relentless radiation that gnaws at its systems. One day, the giant will claim it entirely, drawing Juno into its clouds where it will burn away unseen. Yet this was always the plan, to give everything in exchange for knowledge. Like a symphony, Juno's journey builds toward a crescendo, each perijove another note, each discovery another chord in a cosmic composition written across 9 years of exploration. And what music it has played. Juno has shown us storms that dive deeper than imagination, magnetic fields so vast they carve invisible boundaries in space, and a moon so alive with fire that it looks less like a satellite and more like a newborn planet still under construction. Scientists now even suspect Io may harbor a global ocean of magma beneath its crust, an entire sea of molten rock churning like a restless heartbeat. If that idea is true, then Io is not just reshaping itself. It is teaching us how worlds are born and reborn in fire. The legacy of Juno is not simply in the terabytes of data sent back to Earth. It is in the reminder that exploration is a human act of courage. We built a fragile machine, launched it across 500 million miles, and asked it to touch the storms of a world that could swallow us whole. And against every odd, it did. As Juno's mission edges closer to its final notes, we're left with more than answers. We're left with wonder. If Jupiter, the closest giant we know, still holds mysteries this profound, what secrets must lie among the countless gas giants orbiting distant suns? And perhaps the more important question is this: if we have the courage to send Juno into Jupiter, what else are we brave enough to explore next? Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH.